Hello friends, greetings to all watching the video. I welcome you all to another episode of Convo with Apricus. Friends, our topic of discussion today is atmospheric science and climate change and overview. And to throw light on this topic, we have Dr. Pradhan Parth Sarthi with us. Dr. Sarthi is professor in the Department of Environmental Sciences, Central University of South Bihar in Gaya, Bihar, India. He has more than 20 years of experience in teaching and research. He is also our honorable member of editorial board in International Journal of Environment and Disaster Studies. Welcome, sir. Welcome to Convo with Apricus. We will start the discussion now. Sir, how has climate change affected the atmosphere?
See, there is three components. First is atmospheric science, second is meteorology, and third is climate change. Meteorology is basically the science of weather, and atmospheric science is the science which deals the phenomena happened in the atmosphere, especially from the Earth's surface up to the top of the atmosphere. So whatever the phenomena happening, atmospheric phenomena, that is discussed in the atmospheric science. Now, another science is climate change or science of the climate change. But what is climate change? Before starting to know that what is climate change, we should first understand what is the global warming. Actually, global warming initiates the climate change. So increase in surface temperature, when I say surface temperature, then surface temperature of land plus surface temperature of ocean. The increase of surface temperature of land and ocean is the global warming. And due to the global warming, the change in the weather pattern for the long time period over a particular location is known as the change in the climate. You know, when we discuss about what is the climate over an area or a particular region, it is the almost 30 years average of the weather phenomena over that particular area. Now there is two things. What is weather and what is climate? Weather is differentiation and climate is integration in terms of mathematics. So day-to-day variation of meteorological variable over a particular area for short time period is known as weather, and climate is the long-term change of the weather pattern over a particular area or a particular location. Normally, the 30 years period is taken for the study of the climate. If we get a change in the climate over a particular area in terms of the 30 years, then we can say that climate change is happening there. So this is the basics of weather, climate, global warming, and science of the climate change. Science of the climate change is very, very complicated. It is not a very, very simple issue. Like everybody is now talking about the climate change. Climate change is basically the complex situation that is discussed or deals with the principle of the physics, complicated mathematical equations that is converted in the computer program and that is run on the high-end computer or sophisticated computer to get the prediction of the weather and climate for a certain time periods. So it is a very complicated issue, the climate change.
Thank you, sir. Sir, what is atmospheric radiation? How does it help in climate change?
See, the Earth receives radiation in terms of the shortwave radiation. The sun radiates radiation at different wavelengths. Some of the wavelengths are of shorter, and some of the wavelengths are longer. So sun radiates shorter wavelengths which come to the Earth's atmosphere when it reaches to the Earth's atmosphere, as you know, the Earth's atmosphere contains a lot of dust particles and air molecules, as well as moisture particles. Those air particles, dust particles, moisture particles is influencing in re-radiating, scattering, reflecting, or receiving and absorbing those short wave radiations. So once the short wave radiation comes in the atmosphere, 3 to 4 processes happens in the Earth's atmosphere. When I say Earth's atmosphere, means from the surface of the Earth to the top of the atmosphere, normally 100 kilometers from the Earth's surface. So whatever the short wave radiation comes in the Earth's atmosphere, that is either reflected, scattered, absorbed by those particles or these particles which is available in the atmosphere. So after that, some portion of the radiation reaches to the Earth's surface. When this Earth's radiation reaches to the Earth's surface, Earth receives those radiations and absorbs those radiations during daytime. But in the night time, the Earth re-radiate these radiation into the atmosphere. Once these radiations go into the atmosphere, the wavelength of these radiation is long wave. So these are long wave radiation is re-radiated by the Earth's surface, and short wave radiation come to the Earth's atmosphere. See, when we get a balance at the top of the Earth's atmosphere, means incoming radiation must be going to the outgoing radiation. This is the ideal balance. If this balance is by any means is disturbed, the global warming takes place or global cooling may take place. We should not always understand that everywhere the global warming is taking place. No, there is some places over the Earth's surface where cooling is also taking place, but at many places, since global warming or warming is taking place, so warming is dominating over those cooling places. That's why people say that global warming is continuously happening across the globe or across the Earth. This is the basic things or fundamental things about the warming and cooling of the Earth's atmosphere in terms of the radiation budget. So whatever the radiation that is coming to the Earth's surface, Earth's atmosphere, that must be balanced by the outgoing radiation. If there is an imbalance happens, then we get global warming or global cooling.
Thank you, sir.
So, yes, you may continue.
Thank you for explaining in such a lucid manner. Sir, I want to know, what is the influence of climate change on fine particulate matter and other air pollutants?
See, now these days, air pollutions or particulate matter, which is going into the atmosphere by several processes, by the natural process or by the human beings, that is disturbing whole of the Earth's climate. And these particulate matter or dust particles which is going into the atmosphere, that is not uniformly distributed. Somewhere it is, their concentration is high, somewhere their concentration is very low, somewhere it is dominated by carbon dioxide, somewhere it is dominated by sulfur dioxide. So at the several places, lot of concentration of these particles is happening. So accordingly, they impact the Earth's climate. Suppose that the carbon dioxide is going into the atmosphere by any means, by natural process or by man-made activities. So if a place at a place, the carbon dioxide is going to the atmosphere, there will be cooling over that areas normally or in general. But if the sulfur dioxide is going into the atmosphere by any means, by natural process or by anthropogenic process, so there is the characteristics of this sulfur dioxide to produce the atmospheric cooling. So whatever the concentration of the those dust particle or particulate matter will be in the atmosphere, that will decide either there will be the global warming or local warming, or there will be the local cooling. So it depends upon the which type of particulate matter is going into the atmosphere. As you know that now these days there is the variety of activities which is responsible for emissions of those particulate matter in the atmosphere. But my feeling is that global warming is not a very big issue. Big issue is your population. Until unless you do not control your population, you will continuously exploit the natural things of the Earth's atmosphere, and finally you will disturb the ideal balance of the Earth's climate, and that's why we are facing the global warming and global cooling. So main responsible cause is your population.
Yes, sir.
See, earlier there were also global warming and global cooling, but there were not a very big threat in before 10,000 years or 1,000 years before. Now, why we are getting a threat of those global warming? Because our population is continuously increasing. If we control our populations, I am very much sure that there will be no threat of the global warming.
Yes, sir. Thank you, sir. Sir, what are the co-benefits of reducing air pollutants that also reduce the impact of climate change?
As I just told you, suppose that I am taking two examples. One is the carbon dioxide and another is the sulfur dioxide. Both are having the contrasting characteristics. Sometimes back, I am giving you one example. Near the Iceland, there were the volcanic eruptions. I feel that around 2012 or 2013, there was the 2012. There was the volcanic eruptions nearby Iceland, and there a lot of sulfur dioxide has been injected into the atmosphere during the volcanic eruptions. What happened? The whole sky was covered by the sulfur dioxide, dust particles and other particles, and there was a complete haze type atmosphere, and the total international flights were disturbed due to that. After that, there was the snowfall started over those areas because there were the continuous cooling in the atmosphere, and that is responsible for the snowfall over that area. So this is the contrasting feature of the carbon dioxide and sulfur dioxide. So there is the co-benefit of these particular matter in the atmosphere.
Yes, sir. So, how mitigation options to reduce carbon dioxide, a greenhouse gas, can affect emissions of particulate matter, ozone, precursors, and other air pollutants? Please explain.
See, technologies are continuously coming to mitigate or reduce the concentration of the carbon dioxide in the atmosphere. Recently, IPCC has already told that you have to maintain the increase of, or you have to keep your increasing temperature up to 1.5 degrees centigrade, not above that. So to control that, there must be some technology to reduce those carbon dioxide into the atmosphere. And if you do not reduce those carbon dioxide concentration in the atmosphere, other consequences will be there, like ozone and other things, deforestation or other things will take place due to some man-made activities. So my feeling is that technologies are coming to reduce the carbon dioxide concentration, and it is necessary. This is my feeling. But how much we have developed those mitigation techniques, how much carbon dioxide concentration will be the atmosphere, international politics are still going on. One country is blaming to the another country is blaming to the another country to reduce the carbon dioxide concentration into the atmosphere. So among those things, how the mitigation technology or mitigation activity will take place, I don't know.
Yes, sir. Thank you, sir. Thank you for explaining in such a lucid manner. And I want to thank you that you came here and took part in the discussion and explained the things for the audience in such a good manner, sir. Thank you so much.
Thank you very much. Thank you very much.